Hi, this is Scott Shepard with Honeywell Generators. I'm here at Robertson Heating Supply. Going to go over a few of the products just to get the sales guys comfortable with everything. And we're going to start with the transfer switch, as that's probably the most important and also the one that we have the most questions with. I do want to say one thing also. Honeywell is made by Generac. It is our only private labeled. So if you see products up here labeled as Generac, the difference between the Honeywell products and the Generac is basically the exterior color and the warranty. But that is a Generac product. So I have a Generac transfer switch here. This is a 200 amp service entrance rated. First thing I want to go over is the difference between service rated and non-service rated. If you guys see a SE in the part number, or you see that it has a main breaker, that is a service rated switch. What that means is it becomes the first point of disconnect. So instead of the big main breaker on the service panel, that would be the first point of disconnect in a normal house. When you put a gen set on with a service entrance rated transfer switch, this becomes first point of disconnect. The breaker has to match or exceed the service of the house or what you're backing up. So in this case, the house has a 200 amp service panel. We're going to use a 200 amp service rated switch. All grounding and bonding has to be moved out to the switch also. So that is one thing to keep in mind. It's very important. If you have multiple services, so let's say you have a 400 amp, a 200 amp, and a 100 amp sub panels that are all off of the same meter socket, we will need to make sure that the service entrance rated switch is larger than the largest service. So in this case, it'd be a 400 amp transfer switch. I get a lot of questions on that. I want to make sure everybody understands that. As I'm going to move through, I'm going to show you how this works. Basically, if you guys can imagine the wire that goes from your meter socket to the top of your service panel, we're going to cut that. Coming out of the meter socket is going to go into the top of the switch. So up here on these lugs, what's coming out of your service panel is going to be down here on the T lugs. That is the load to be transferred. The E lugs here go to the generator. Think of that as emergency power. What happens is we use low voltage wire, and that will read the frequency of utility. Utility has its own specific sine wave, and we're able to read that. What happens is when it drops below 80% nominal or 80% of what it should be, the generator senses that, sends a low voltage from the battery here into the coils, and we transfer. Does that automatically. One thing I want to point out, so you guys can see this, there is a blade here. We actually have a physical disconnect that happens. Some of our other competitors don't have a physical disconnect. The reason that's important is if this gets hit by lightning or if there's a surge, there is not enough voltage that can be carried through here to actually burn everything out. I've seen some of the competitors where they've been hit by lightning, it's blown the actual gen set 15-20 feet off the pads that it's on. It's a very bad thing. So we actually use a physical disconnect. That's very important. One of the other things that we get all the time is if the homeowner sees that their neighbor's house has lights, has power, but their generator is still running. That generator is going to keep reading that frequency for up to 5 minutes to make sure we have good, stable power. By showing you that there's actual physical disconnect, there is no possible way that we can have generator power and utility power on at the exact same time. That is why I show that. The other part I want to show you, so that's these two coils. That's what either make the transfer or bring it back to utility power. Then over here we have what we call the SACM port. This is the smart AC module. What we're going to do with these four right here is we're going to load manage, meaning we're going to automatically turn on or turn off the load depending on how much power is available through the generator. All we're going to do on these is break the thermostat wire, bring it back here to the transfer switch. It will automatically turn on and off that air conditioner. One of the interesting things with this is there's a 5-minute delay. This is on purpose because the capacitors within inside an air conditioning unit usually have a 5-minute delay already built in. So even if the homeowner wants that power instantly, it actually won't happen until those capacitors dissipate in the AC. So that's why we set the 5-minute delay. AC1 would come on as long as the generator is good and does not bog down. We would 15 seconds later bring on AC 2, 3, 4. If there is an issue, let's say 2 overloads the generator because they have all kinds of other electrical appliances on, it would lock that out for 30 minutes, then come back and try it again. So the homeowner will never be without that power but they'll still have that. So that is a quick overview of the transfer switch. I'm not going to get into the wiring or anything in this video, but I do want to make sure that you understand the difference between service rated and non-service rated. Where we would use a service rated would be where there is no other form of disconnect. So again, if there's an industrial or commercial application where they have a separate form of disconnect, then we could go to a non-service entrance rated panel, save that customer about $300. Majority of the time you're going to have a service rated panel.